right, so now for example number 3.
Yale guy never followed me back then.
Yale
You
guy.
followed? Wait, who did you follow?
Example number 3, I'm recording. A train moves along a track at a steady 75 miles per hour from 7 a.m. to 9 a.m. Express the total distance as an integral. All right, so here's what we're going to do. We have time and the velocity. Now, the reason I'm writing it this way, what are they asking us to do? They want a distance, right? Now, a distance is really a displacement s. And we know that the velocity, which is really the derivative of displacement, is 75. Right? Remember that stuff?
Yeah.
Yeah.
Okay. So we know that the velocity is a constant 75. So if I were to graph this in terms of velocity, I would say 75 here, and it would be a constant this way. But what I want to do is I want to go from, say, 7 a.m. to 9 a.m. And so, basically what I want to do is I have to find the derivative of displacement by taking the antiderivative of the velocity, and then I'm going to evaluate on the interval from A to B, which is from 7 to 9.
Can I borrow one of your computer guys?
Yeah, whichever one of you guys
Who
want to
wants
do.
to come fix my latest problem?
So what it means is I want to calculate the area under the curve from here to here. Now we know that he traveled for 2 hours at 75 miles per hour, so the answer is what? 75 times 2, which is 150. We know that. But now we gotta write this formally. So to find the area under the curve of this, I'm going to take the integral from 7 to 9 of the function 75 dt. Now, to get that answer, we know that we're just going to say 75 times 9 minus 7, which is 75 times 2, which is 150. Now, you got to write all that stuff down because it's important, especially this stuff right here, because we're going to use that information to calculate these integrals. Okay? That's it. Does anybody have any questions on what we just did?
Nope.
Now I am going to add one little extra thing, so turn your calculators on and warm them up, because you can actually calculate this on your calculator. Now I could plug in this function on the calculator and graph it and find the area under the curve that way, or there's a program on your calculator that'll find the definite intervals for you. Now, my function is just 75, right? So I would just graph 75. Now, I have to change the zoom a little bit. I have to adjust my window. So my x value is from 7 to 9. So let's just do like from 6 to 10. And then my y value would be like from, I don't know, -1. Let's do -1 to 76. All right. So now if I graph this, I'm going to get a little teeny tiny line. And did I do 6 to 10?
Mm-hmm.
Yeah, is that what I did?
Yeah.
So now I could calculate this by hitting second trace and see my little integral symbol there. So if I choose option number 7, my lower limit is 7. My upper limit is 9. And then my calculator will calculate the area under the curve, which basically is 2 rectangles. That's 75 times 1 plus 75 times 1. Does that make sense?
Can you please show how you put that in again?
Yeah, sure, no problem. So if you hit second trace second trace. Option number 7 is how we find the area under the curve. So you choose 7. My lower limit is 7. Hit enter. It'll ask for the upper limit.
Wait, would you type in the y value?
75. That was the function, right?
Oh.
And then the upper limit is 9. And it's just going to redraw, but it's the exact same thing, which is 150. Now, another way to do it is you actually have an integral program on your calculator. So if I close this out, and this does an approximation method, and basically what it does is it lets delta x equal like 0.00001 or something like that. What I'm going to do is if I go into second catalog, and I think it's nint, so I want to find the ends. Is that number 8? No, well. And no, it's nint. Or maybe it's just int. fn. Okay, thank you. Your textbook says nint. It depends. If you have an older calculator, the command was nint. But if you have a newer calculator, I guess it's f. I just can't quite see. I think it's the sign. No, that's e, but that's okay. There we go. Yes, here it is. And that's a function integral, or it's a definite integral. So that means you have to have a numerical value for the lower and upper limits. Because you can do a generalized integral, an indefinite integral, and a definite integral means you have to know what they are, what the upper and lower numerical values are. Now the way this works is the first thing we have to do is plug in the function. What was our function?
75.
75. Hit 75, comma. Now what variable are we integrating over? X.
X.
Right? The textbook says t, but we graphed it on the calculator in terms of x. And then what is my lower limit?
7.
7. So I'm going to hit comma, lower limit, comma, upper limit, 9. Just like this. So I'm going to wait until you guys have that entered in your calculator exactly the way that Mr. Adams does. Now we already know what the answer is, don't we?
150.
It should be 150, right?
Yep.
Okay. So now if I hit enter, guess what I should get?
150.
150. Does that make sense?
Yes.